My name is Lex Hecht. I'm a tech lead at BizTalk 360, working for both the BizTalk 360 products and the Atomic Scope products. Today the next session is from Thiago Almeida. Especially nice to meet him here for the very first time, after he has also been very involved in the community, and we've worked on some projects years and years ago in the community when Thiago still was living in New Zealand. Meanwhile, he has moved to Microsoft, and you are working at the commercial software engineering team. Yeah, and that's also what his session is all about. He is going to tell about how customers worldwide are using the serverless products in all the different use cases. So, Thiago, the floor is yours.
All right, thank you. Sure. Thanks. Okay, so this session, it's going to be a little bit different. I'm not going to cover the products themselves, but some random stories of customers that we've been working with, and mostly using serverless technologies on Azure, including all of the technologies that you saw today. The team that I work with or work on at Microsoft is called Commercial Software Engineering. It's a different CSC from the other CSC guys that presented before. But what we do is we work with customers, code with them, learn everything that we need to learn to help them get to where they want to with Azure. And then we prioritize that back with the product group. So I'm in contact with most of the folks that have been presenting throughout the day to influence them based on what we've been gathering from customers as well. So that's where CSC is in. And we have these different technology domains, and the one that I'm a part of is the serverless and messaging. So that fits really well with this conference and all the folks that have been presenting so far. So my session, that's a rough guideline of what I'm going to cover. The first one is, what do I mean by serverless? There's different definitions. We can spend days discussing on what is serverless, what isn't. Is Azure Storage serverless? So I'll just cover what I think serverless means, and then I'll go through a few different areas and customer projects that we've had so far. Okay, so the definition of serverless that I like is this one. It's the scalable and reliable event-based compute experience for code and workflows that will accelerate the lifecycle of applications while hiding the infrastructure and providing auto-scale and micro-billing. So what it is usually there's events involved, code or workflows, and I like to make the distinction because on Azure, we have Azure Functions, we have logic apps, and we have durable functions as well. So both, to me, as long as they are event-based, they are part of serverless. And then the benefits that it brings is it hides most of the infrastructure from you, while still providing auto-scale and micro-billing as well. So going into some of the scenarios, the ones that even the rest of Microsoft likes to talk about, this is very, very common ones. We have web and mobile API backends, and you've seen the presentations about API management, so that's the perfect solution for it, especially now with the consumption plan. It's very popular solution for creating that facade of what is the definition of your API, and then behind it, you implement it however you like. IoT and stream processing is becoming more and more popular. Bots, as you saw this morning from the customer Shell present about the bot that they created, that's also a great place for you to implement what's behind the bot using Azure Functions or logic apps. File processing, I'm going to go into more detail about that one pretty soon. Cron jobs, scheduled task automation, and software as a service automation and integration as well. So these are very popular ones. So on file handling, we have this thing inside of CSC where we create challenges for attendees of this event, and they have to come in and figure out how to solve those challenges on Azure. There's a coach per table, but they just have an empty Azure subscription where we're putting things into the subscription for them, and they have to solve that challenge. So challenge 6 of the serverless open hack is this one, where a company receives transactions from trading partners via flat files. They are put into Azure File as batches, where the batch ID is in the file name, and they can come in any order at any time. So your team needs to create a way to process the file as a batch, but only after you've received all 3 files, right? And then join up the content of the files and save that into JSON, usually into Azure Storage or Azure Cosmos DB or Azure SQL, for example. So a few options that we've seen people solve it with Azure Serverless are, as the files are coming in, just load that, have an Azure function or a logic app that loads the content of the file into blob storage. And then you have a different timer function that checks from time to time which batches have I received the 3 files for. Then it picks up all the contents of those 3 and processes those. This is the easier one to implement. The next one is, as the files are arriving, you make a query back to Azure Storage, because you can write a query back and say, do I have 3 files for this same batch ID? If you have the 3 files, then process those. Pretty easy. This one I really like because you can use Service Bus with sessions where the number of files is in the header of each message. So that way, you can even pass in, and we work with a customer that is actually doing this. They pass in the message of Service Bus the definition of the schema of the files. And then once you've received all 3, you can process those based on the session. So the same processor will be receiving the information, and then you know when you receive 3 files. But my favorite one, my second favorite one is Azure Durable Functions with a sub-orchestrator per batch. So as the files arrive, you extract the batch ID and send a message to the orchestration to say this is the ID. And all 3 messages, all 3 files, once they arrive, it'll end up in the same orchestrator that then it knows when I've received 3 files, then I can process this. But finally, my favorite is using the logic app's batch trigger, right? As the files arrive, there's a receiver logic app that then extracts the batch ID, sends it to the subsequent batch triggered logic app, and that one only releases once it's received the number of files. It's the pretty easy way to implement, and I'll show you pretty soon. So to talk about a customer that we've worked with that ended up implementing this, GE Aviation, they are receiving raw files from their customers, and they also have their own information about transactions, and they wanted to put those through some Python code to clean up the files first. So they arrive into blobs, get triggered through Event Grid, they clean it up, and they put it into separate cleaned containers into blob storage. Once those cleaned messages show up, it triggers a logic app, the pre-batcher one, the pre-processor one, and this one will extract the file name, pick the batch ID from the file name, and send it to the processor. So the processor will eventually call the reconcile function once it's received the right number of files. So just to show a quick demo here, this is a cleaned up version of one of the Python functions that they're using. So as you can see here, there's Python, it's receiving calls. So this is the reconcile one, and then the clean ones are there. And you see it's just an HTTP triggered, HTTP-based Python function because it's Event Grid that's calling it, so it will come through Event Grid and call this. And if just to show you, I can start it up here, and it'll run Azure Functions locally for me and give me the URLs that I can make, that I can call. I should have, at the end here, I have a breakpoint just for us to see it. So in my reconciled place, I don't have any batch 10 files, so I'm going to make a call to it to get the cleaned versions of the batch number 10. As you can see here, it's passing in the batch 10 and the 2 files batch 10. It's making a call to my local function. And now it's hit my breakpoint just to show that it's actually debugging locally. And I can continue here, and it's going to write out that blob, the reconciled version of combining the two files, doing some pandas-based ML on top of it, and writing it out. So if I refresh it here, I should have a batch 10. Yep, there it is. So pretty straightforward. I also have this function running on Azure, all three functions, so I can create a new batch from the beginning. So if I go to the raw input here, I'll copy this file over to my raw one, and that's gonna upload the file. And this is batch 14, so I'll copy batch 14 for the other one. So this will trigger my two first Python functions. They're gonna go into their cleaned folders once they get cleaned up. And from there, they're gonna trigger the logic app to get to reconciled. So just to show you those two logic apps, I've got the ingestion one. And if we look at the history of it, you see that for the last time I ran this, it picked up two files. And for each one of those, it's extracting the batch ID from the file name, and the prefix of the file is the batch ID, batch 13, and passing that in as the partition name. So the partition name is what binds together this instance of batches that the second logic app is going to trigger from. So that's the important bit, is to batch name is what you set up in the batch triggered logic app, and then the batch ID or partition name, is what ties together that run. And then finally, if we go to the batch processing one, we'll see for the last time it ran, it got released with two messages for batch 13. So it's an array of two messages, information about the files. And then it calls that same reconcile function that I showed you running locally with the information about the three files. So this is pretty powerful, and that's what we used with that customer to match up when batches of files arrive. Of course, the real scenario, they would have more files and stuff, but that's how you can use the batch trigger to act upon any number of messages that are part of the same batch that need to be worked on at the same time. All right. Oh, wrong deck. Here we go. Okay, so some use cases that we've seen customer use Azure Python functions with automation scenarios. Python is very useful there. Just like I said, data cleaning, like I showed you now, data cleaning, wrangling, pre-processing, data retraining and training of time series-based data as well, inferencing and scoring of small data ML models. Around 50 megabytes ML model sizes is what we've seen work really well at the moment. And this is a link to my team's list of Azure samples with Python functions. So if you ever need to do like LDA topic modeling, inferencing, time series forecasting, these are all, the last one is the one that is related to the demo that I just did, data cleaning and reconciliation as well. So some pretty good examples there. For the batch file version of things, there's one that, if you want to see how it's done, it could be done with the durable functions. Then that first link from Brandon, my teammate, shows a couple of examples there. There's a good write-up about the claim check pattern as well. And then finally, if you want to read up on the batch trigger for logic apps, that's the link to the documentation there. Okay, so on to the next story. This one it's kind of an interesting project that we worked on because we noticed a limitation in the Azure billing APIs where for blob accounts, you get information about the blobs that, you get the billing information for up to the account, but you don't know per container. So what we did is we wanted to track, we basically split up customers per container, and we wanted to see how much data each customer was using at any time. So what we did is we used Event Grid whenever either the storage account got created or deleted, or when a file got added or deleted from there. We extracted the information about which container and customer were related to that container, and we wrote the bytes written and bytes deleted into a database that we can then write reports on and on charge or each customer for whatever amount they wanted to use. And this is, there's 10,000 separate customers for this customer from the Azure customer, so they couldn't just keep creating one storage account per customer. They had to go with the container option. So that's another really good usage of Event Grid and Azure Functions. Down there is the sample code if you want to check it out. It's pretty straightforward. It's two Azure Functions with an Azure SQL database, and the functions are triggered from Event Grid. Another one that I'd like to talk about a little bit is durable functions. So there's this customer in Brazil called Direct One, and they basically wanted to nag their customers on a daily basis, or they wanted to nag the customers of their customers on a daily basis to pay their invoices. So they wanted an escalation flow depending on the previous state, and their usage have spiky workloads as well. So it's a perfect scenario for serverless. And they wanted a pretty complex orchestration, and they were very keen developers, so they preferred to write the code. Of course, this could also be done using logic apps, but they decided to go with the durable functions approach, and they ended up creating it so that, have you paid the invoice yet? No? Okay, let's send a nice reminder via SMS to the customer. 24 hours later, no, let's send a more serious SMS. Another 48 hours again, let's send an email. And then finally, if they haven't paid after 72 hours, then they print out a boleto, the invoice, and that gets sent to their, and then from there, I guess they send a repo man to your house. So this is how the orchestration looks like, and just a part of the orchestration written in durable functions, where it sends an SMS payment collection. It triggers the activity trigger that will actually send the Twilio SMS message to the customer. And then at the bottom there, you can see there's a timeout, and it'll await for whatever happens next. Either it gets an external activity to say that will have the information that instance was paid for, or there's a timeout, so it needs to go down to the next level of nagging. So that's a pretty interesting use case. Another one that we worked with, Fujifilm. This is when I found out how much they love baseball in Japan. And they have, for all the Japanese games of baseball, there's photographers that take photos of the players, and then they upload all those images, but they were taking quite a lot of time to tag which player was in those photos manually. So we've worked with them to implement this solution using a pre-processing Azure function that then calls in parallel using durable functions, one that uses the Face API from Cognitive Services, and another one that works on a custom model that they've built as well, that Fujifilm had already built to try and classify it as well. And then once those two have run, they join up the data and put it into the database to associate that photo with the analysis results. So it used to take like 40 minutes for them to manually go through each image and tag it, and now it takes less than 2 minutes with this approach. So it's a pretty cool scenario as well. Part of that work with Fujifilm that we had, what was interesting is they wanted proper CI/CD, they wanted unit testing, they wanted handle exceptions. So Tsuyoshi from my team that worked with them, he created all that first example. It's a sample that he created just to share the lessons, but if you go to that first GitHub link there, he shows how to do unit testing for durable functions, dependency injection, coverage report for based on how much unit testing do you have against your code. So I'd recommend checking that out as well. The other thing that I want to call out is the third link there is no downtime deployment. This is something that people take for granted when they're using Logic Apps, is that Logic Apps, you basically just upload or edit the Logic App, click Save, and it's already live and running. And the Logic Apps that are already running, they'll keep running with the version that they had. But when you try and do it all with code yourself, including durable functions, then you have to figure out how to do that, right? So there's more code, there's some extra stuff that you need to think about as well. So Tsuyoshi went through some lengths to try and implement that or find out approaches how you could do blue-green or deployment with durable functions. So we see customers, and I love both technologies, Logic Apps, durable functions. I've worked with customers with both, and they're super powerful solutions. So a lot of times it comes down to the customer prefers to they're all just developers, and they prefer to keep developing with code. So they tend to navigate towards durable functions. But Logic Apps, from an integrations perspective, and with the number of connectors that you have and all the built-in features that you get, it's definitely always taking a look. And I guess I'm preaching to the choir here for you guys. Also, durable functions seems to have a good place for just orchestrating other functions. So if all you need to do is call a bunch of other functions to do more code and wait for them to finish, or fan out and fan in, then durable functions is a good idea. But if you're doing something more complex that needs to use connectors or call sub-orchestrators quite a lot, and et cetera, then you start looking at Logic Apps as well. Durable functions, of course, has a portable runtime with the local debugging and et cetera that it provides. But the management experience for Logic Apps, it has a really rich Azure-based portal for the management, which you basically have to implement yourself with durable functions. So consider both, but play where you think it's best, and or do what we do, and we try both at the same time and see what works best for that customer. All right, so the next customer scenario, and I usually have a demo for this, but I wasn't going to have time to show it. But we worked with a company called Johnson Controls, and they have, at least in the US, they released this glass smart thermostat. And they were running their backend all in VMs, and they wanted to move to a more PaaS-based architecture. So they started working with us, and we ended up implementing with them a solution that includes IoT Hub. In IoT Hub, it has this built-in solution for you to route messages based on the body of the message. So the devices are sending, for example, when you first buy the thermostat, install it at your house, and you want to register it, that as a registration event, and we're just routing it to a separate event hub. Then you start pairing the tool with your phone, or if you're doing updates on the settings to say, I want my house to be warmer today. So all of those are coming into Azure from thousands of devices, and they're coming into IoT Hub first because it has the connection with the JCI glass thermostat. But then from there, it goes into a specific event hub, and those event hubs are triggered by then triggering Azure Functions to work on that data. So save it to Cosmos DB. One interesting one is that third one there, where it goes from device to IoT Hub to event hubs. An Azure function runs on that, saves it to the database, and then we need to alert anyone from the house that has their phone paired with it. So it goes down to SignalR, and again, a SignalR triggers something on the phone to let you know, oh, someone updated the settings at your house, so it might be warmer today. The other one, the last one, is coming back as well. So when there's some weather update that we need to push down to the JCI glass thermostat, it gets triggered on Azure by a separate service that puts a message into Event Grid for each geolocation. Then that either picks up the information from a cache or from a database and pushes it down back to the devices as well. Last I talked to the team, they had already 20,000 of IoT devices simulated, but by now they're already running in production because they're selling the solution on Amazon. And they really enjoyed how they can do an event-driven architecture for this, even for IoT as well. So the separation of concern for the different types of messages, and it can scale up. That was something that they wanted to be ready for, is if they needed to keep scaling up, then with this architecture, they can always scale up more and more with both Event Hubs and Azure Functions. So there's some links here. Simple IoT device simulator if you want to simulate the IoT devices. There's a really nice solution for streaming at scale that shows how to use Azure Functions to trigger off of Event Hubs and to save to Cosmos DB in a very efficient manner. And I think it was the other CSE, MSIT, that wrote this really nice Java-based sample that has a whole bunch of Java functions as well, that is an inventory hub, but it's simulating point of sale, so it's kind of IoT hub into Java functions that then does something with it. So I recommend that link as well. All right, getting there. Just before I get into it, just because I just mentioned that Azure Functions can scale up pretty well with IoT, with Event Hubs, this is a test that I was running for that same scenario, and I wrote an App Insights query against a premium Azure function. And as you know, Azure Functions Premium, it keeps one instance running. So you can see there in blue, there's that one instance that's already running and ready. And as soon as load starts to show up in Event Hubs, it'll start scaling up. And this graph shows it pretty well, where it scaled up the instances up to 10. Then once all the Event Hub messages were processed, it started to scale back down. And it preempted that the load was going to start up. So the load never really caught up to the number of instances, and no messages were dropped, or there was no delay in the processing. And then finally, we're working with a few customers now that are on the same path of what most of the team have been talking about today, where they're migrating their enterprise integration solutions from BizTalk, from IBM Sterling Integrator, from Web Methods, from a bunch of others onto Azure. And there's quite a few patterns that start to show up where you have, pretty much like the MSIT team showed, there's a pre-processing step that you implement. From there, you go into logic caps with sessions that then goes into one of many canonical logic caps. So that will dynamically identify which map to apply. It maps it to your internal definition, say if this was a purchase order, internal definition of your purchase order, and then from there, whatever needs to be done for a purchase order will happen, and potentially send it back into on-premises to a back-end system that is the final record of truth for that order. And then we've been implementing the reverse with other customers as well. One thing that I'd like to show you, hopefully, it's still loaded here. This customer, one customer that we're working with now, they wanted to have in-order processing for everything down to the purchase order number. But when we receive messages from them, we only know what the original customer was. We don't know the order yet. So we wrote a tool, we wrote the logic app that is the entry point for that, and the session ID for for Service Bus is the customer number. And then in here, we're processing those messages and extracting the shipment ID or the customer or the PO number, and then sending it to a subsequent Service Bus queue, but with a new session ID that is both the customer and the PO number. So whatever is picking up from there, a logic app that's picking up from that second queue, it can then scale out to however many PO number customer ID combos that you have. So the first one is trying to process as much as possible, extracting PO numbers and putting into a second queue, and then the processor from there will scale up quite considerably to be able to handle all of those POs and then do further processing. A couple of things that we've learned. So peak lock on the message, of course, and then the sequential convoy pattern where you get a message from the queue, and then you start, you decode that first message, do a for each on all the good messages from there, send it out to the subsequent service bus with with the extracted new session ID, that's the customer number plus the XPath to the B204. I think the XPath can be improved a little. But then after that, once you have that session going, from the same logic app, you just keep picking up messages from the session until there's no more messages. So once the logic app is triggered, it will start picking up as many messages as possible from that first queue and process them as fast as possible. So it's not like it's being, there's an instance of this logic app that gets triggered after each message. It's just picking those up and processing them in order as well. Of course, the for each loops here, they have the parallelism set to 1 so that it is in order processing. Another thing that is interesting here is that in parallel, and this was a tip from Kevin, I believe, we have a renew session lock running in parallel every 45 seconds so that the session stays with this instance of the logic app while it's running as well. And then finally, the last thing to call out is currently we're using one service bus connection to receive and to process from the same session, but for sending, we can use a different one if we want to parallelize the service bus connections as well. Once what Divya mentioned, once it becomes a built-in or a native connector, then this might not be needed anymore. But for now, this is interesting to split out. If you have one session from one queue coming here and one session to another queue going out, you could create different API connections to split up those two as well. So with this, we managed to get a pretty good load going as well. In the slides, I just have print screens from there in case it wasn't working. And we managed to process 1 million messages in about an hour. This doesn't include the X12 decode and sending 997 spec, but it still shows a really pretty graph for you of processing service bus messages using logic apps and implementing the sequential convoy pattern. And the last part is, while I talked about pay-per usage as part of serverless, we are getting into more and more customers that are enterprise customers in the financial industries or in healthcare, that they have this very strict requirement of everything needs to be in a VNet, and we need to control what goes in and out of that VNet. And that's why that's where you will most likely end up with an architecture diagram that looks kind of like this. App gateway or Azure Firewall or one of the traffic controlling solutions around your VNet. API management that is injected into the VNet as well to make that between outside and inside, and also to expose internal APIs. An app service environment for hosting both your web apps and Azure Functions. And then integration service environment that we talked about today as well for all your logic apps with connectivity to on-premises through ExpressRoute or a site-to-site VPN. This is becoming very, very common. And one interesting, this Azure Solution Blueprints are very interesting. They've implemented, they only show app service environment, VNet, and API management, I believe. It's still missing integration service environment, but hopefully that'll get added there. But it's just an interesting set of ARM templates and scripts, and also some extra information from the Microsoft Service Trust team on how to implement this in a secure fashion, how to set up the VNet, and et cetera. So I'd recommend checking those out. And then, of course, once you have that base in understanding of how it works to automate it, you can just add the integration service environment in there. So that's all I had so far. There's quite a lot of other customer projects that we're working on, and a bunch of different customers that we're going to keep working with to implement Azure Serverless and Azure Integration Services for their projects. If you have any questions about what I've just presented, just come and talk to me. I'm here for the rest of the day. Otherwise, get in contact. I'm Thiago Almeida. That's my Twitter handle, but it's also thiago.almeida@microsoft.com if you want to email me. So with that, that's the way out for me. Thank you.
cove.co.